So the title of my talk is Automated AI Analysis of the Lustre-Development Mailing List. That's really not the total focus of my talk, but I figured that was the best way to get it past the program committee, and then I could change the slides and talk about whatever I wanted. So I will spend a couple minutes talking about that. So first of all, I was asked to work on this project, and let me try and phrase this carefully because, as I just mentioned, my boss is in the audience. Before I talk about the project that I'm working on, I want to talk about the motivation for it. And so I showed up and they said, work on this thing. And I said, why? And they said, well, because it's important. And, you know, like, that's good. And my boss is great and amazing and super smart and wonderful and all those positive attributes. And so I did trust him. But I also wanted to see if I could get, you know, maybe a more methodological motivation as opposed to just being anecdotal. So, you know, what we heard anecdotally, and I have seen various speakers talk to this already. Tom from HPE, I think, had a slide that looks sort of similar to this at the beginning of his talk. You know, so what are challenges with storage systems in HPC? You've got very long release cycles, resolution periods are long. You know, your diagnostic tools are maybe not as good as you might want them to be. And you do have these sort of onerous requirements of, you know, arcane expertise. Okay. Also a little worried seeing Andreas sing in the front row with the sort of dubious look on his face. So, you know, so as I sort of thought about, you know, is this true and what are challenges in distributed storage systems? I spent some time thinking about how could I come up with something, you know, that's maybe a bit more quantitative than just anecdotes, right? So I said, well, let me take the Lustre-Development mailing list. Let me organize it into threads. And for each thread, let me ask AI, right? Specifically, I used the API for ChatGPT. And I said, for each thread, what is the topic of this thread? And, you know, was the question answered? And I also, just for fun, threw in some stuff like, did people seem angry? Were they frustrated? You know, what was sort of the tenor of the conversation? But basically, what's the topic and was their question answered? So this is the data that I got. And you can see, right, that deployment and stability are really what are the major conversations that are happening. I did show an early version of this talk in these slides, Peter Jones, who pointed out that, hey, you know, notice this knee in your curve. There's this interesting inflection point where the slope of those lines really decreased. So I think that's really nice. It does show that maybe since around 1.8, Luster's become a lot more mature, a lot more stable. But still, right, deployment and stability are the dominant conversations. And I'm going to reorganize this same exact data for those of us who like pie. Here is the data in a pie chart. And again, you can see, right, deployment and stability are dominating the conversations. As evidenced by last night, I think I know the answer to this question, but for those of us who like bars, here's the data in a bar chart. This is slightly different, right? So this is for each of those topics, what percentage of those threads were actually answered. You know, and you can see actually deployment is the highest. So people are pretty competent and able to answer other people's questions about that. Announcement is low. I should probably take announcement out of here. You don't really expect an answer to an announcement. But so the data is I think, you know, underlying the work that we're doing. And for those of us who like Andreas, I won't ask for a show of hands, although it'd be safe, he's in the front row, he won't see. You can see, right, that maybe there really is this expertise for this requirement for arcane expertise, right? That Andreas answers a huge number of questions. When Andreas doesn't answer your question, it's much less likely to be answered. So, right, the summary of that mailing list analysis, I'm not trying to bash Lustre. I'm at LUG. That'd probably be a bad idea. I think Lustre is great. I'm one of the original founders of IO 500, and I think one of the things that I really like about IO 500 is it's shown the world that Lustre is really pretty amazing in a way that people didn't necessarily have that quantitative evidence before. And I'd like to expand this for more systems, but I do feel more confident showing up and saying, hey, why am I working on this project? I haven't told you the project I'm working on yet, but why am I working on it? I do feel that I have an answer that is a little bit less, anecdotal than just, oh, my boss told me to. So you might ask, well, why isn't this a solved problem? There's armies, really, of developers that are working on this. You can go into, any of the main clouds, and they've got these amazing, awesome pull-down menus. And you say, configure and deploy. I want a Lustre system, with these specifications. And boom, it's there, right? And there's armies of enterprise developers working on this as well. And I think Glenn Lockwood really sort of answered this question of why isn't it a solved problem? It is a solved problem, but it's solved in, the special sauce. Right. So all of that is magic that's happening behind the scenes when you go to the cloud and you say, give me one of these clusters, run in Lustre, and boom, there it is. There's a lot of arcane expertise going into creating special sauce recipes in the background to make that appear as if it's just magic and easy. So, looking at this, right, what can we do to improve the lives of current admins to make the configuration and the deployment of these tools easier? We're working on this tool called TASI, a tool for agile scalable storage infrastructure. It's automation for, configuration, deployment, and testing. One of the admins at Los Alamos, also sitting in the audience here today, Thomas Bertschinger, sort of summarized it by saying, hey, John, this happens to me all the time. There's a bug in some particular version of our storage system, be it Lustre, be it whatever. I actually have a reproducer, and I see on the mailing list that somebody has a patch. And so I want to, I'm not going to run this, I'm not going to apply this patch on day one to our big production system. So I'd like to be able to spin up a small system, run in, distributed system X, Y, or Z, apply with version V, apply my patch P, and test with my reproducer R. So that's what we're trying to do with this tool called TASI. So with that, I'm going to give you an update as to the current status of this tool TASI that we have. I'm going to go through a basic workflow. First, I'll just talk briefly about the different actors involved in the workflow. So TASI is the control agent. That's the software that we're developing. You've got an admin. That's the human in control. In a Git repository, we're storing configs and tests and outputs. You've got software repos to fetch the particular software of interest. You've got a virtual cluster. It's a connected set of virtual machines, some virtual machine management software, and finally, a place to store pre-created images. So before I actually get back to that workflow, I am going to show you a workflow on this exact slide. Just sort of talk a little bit about what is the config file, right? So what the admin is going to do is the admin is going to edit a config file. TASI is going to say, oh, okay, the admin committed a new config file. I'm going to parse that config file and do as I've been asked and get the results back to the admin. Andreas is putting on his glasses. I've piqued his interest. I can now proudly say that my talk is successful. Thank you, Andreas. Two things, Andreas got old and I'm giving a good talk. I think that's what we can learn from that. So the essential elements, or as Andreas pointed out, somewhat insultingly, no, it's just that my font was too small. Thank you. Thank you, Andreas, for that. So it's a bit obfuscated, the current config file, but essentially what it is, it specifies, hey, I need a host operating system with some base image, some amount of RAM. I want to run, right now it's limited to Lustre. I want to run Lustre, pull from this repository. I want to run this version or this tag of the software, apply these patches, and I need a backend, be it ZFS or LDiskFS. If it is ZFS, where do you fetch ZFS from? What version? And any patches for ZFS as well. And a specification of the cluster. How many clients, how many MDSs, how many OSSs, the MDTs, the OSTs, and hard drive sizes for each of the targets. And finally, a test script, that reproducer that Thomas talked about. So the basic workflow, the admin just updates a config file in Git. So Tassie says, okay, there's some work to do. Tassie's going to go out to NFS and say, do I already have gold images pre-created for these particular versions with these particular patches, yes or no? If it has them, great. If it doesn't, it's going to fetch the software. It's going to apply any specified patches. It's going to build those images. It's going to stash those images back into NFS. Not shown, it'll spin up an initial Bootstrap virtual machine. Then it sets up the cluster, right? So on the basis of that config, it's going to create some number of virtual machines. It's going to then configure Lustre on those systems, set up the servers and create the mount points on the clients. Finally, it's going to run any specified tests, and it's going to put the output from all of this work that it did back into the Git repository at a location where the admin will be able to view it. So what are the tools used? The control agent is all in Python. For virtual machines, it's using libvirt. It's using Ansible playbooks for installing and configuring Lustre and ZFS. It's using Git. It's using NFS. Okay. So just a little bit of performance data. So the very first time it runs, it takes a fair amount of time, just a 4-client system with 2 MDS and 2 OSS. Creates that Bootstrap virtual machine, 20 minutes. Then the Gold Lustre client is 24 minutes. Gold Lustre server is 42 minutes. That's a little bit longer because it also has to build ZFS. Client doesn't have to build ZFS. Then it uses libvirt to create the cluster. Then it configures Lustre on that cluster, tests the system. The time for the test is sort of independent. That's whatever the admin puts in. Right now, I'm just doing a simple MPI run of some IOR and testing a little bit of LFS stripe, for example. If you have the gold images already created and stashed in NFS, something I've been calling cold gold, you can bring that time for the same exact config down to 33 minutes, as shown here. If you have warm gold images, if they're already loaded up into the RAM of the physical host machine, you can bring it down to 19 minutes. And then I just did a little bit of client scaling for fun, right? So you can see that it goes from, about 25 minutes to about an hour and a half to run up to 20 clients with 2 MDS and 2 OSS. Just for fun, I also just threw in, hey, can you just edit the config file and make more MDS and more OSS? And good news is, yeah, you just edit the config file. It just worked. So I was happy about that. So what are next directions? This is new work. We've been working on this probably for maybe about 8 months now. So where do we want to go next? We want to do a little bit more flexibility for Lustre specification. We've only worked with the ZFS backend. Be nice to make sure it works with LDiskFS, for example. For performance, you can see if the client scaling, all of the Tassie control agent is just doing things in serial. Probably given that I'm supposed to be an HPC expert, I might consider trying to parallelize that at some point. Better CI/CD. Right now, it's not actually integrated into CI/CD. It's just manually running something that looks to see if there's anything new in Git and puts it back into Git. For cluster deployment configuration, Lano's working on another tool. There have been talks given about this. You can Google it. It's a tool called Ochami. This is another tool for cluster specification. So when we first started working on TASI, Ochami wasn't ready. So I'd say fully 2/3 of the work that we did should be able to be replaced by Ochami as soon as Ochami is ready. And we're starting that effort now. So all of the work just to get the virtual machine cluster up and running, get passwordless SSH, all these sort of things is really not related to what we're trying to do with TASI, but it had to be done. Okay. We'd also like to be able to, work with cloud systems, right? Sort of other tools that can give us a cluster and then apply TASI. We'd like to be able to work with hardware acceleration, work with actual physical storage devices instead of just virtual fake disks in libvirt. Like to expand this work to more than just Lustre, Hammerspace, BGFS, or Deos are some of the systems that we're targeting for next, right? So keep the rest of the TASI infrastructure, right? But just swap out Lustre. Like to be able to use it for not just file systems, but maybe key value stores, maybe object stores. Finally, decomposability, disaggregation, use this to look at NVMe over Fabric. So in conclusion, it's soon to be an open source tool, right? I think one of the ways to think of TASI is we're reproducing in the open what Azure is referring to as their special sauce, right? Making that available for everyone. Flexible, agile, dynamic storage, confident, happy sysadmins. Please email myself or Dom for more info or feedback. Just for fun, on the right side of that graph, because I was doing all this work with ChatGPT, I said, hey, make me a picture of, happy, confident sysadmins. It did it. Then I said, now make them VHPC admins. And someone else pointed this out. The difference is they got older. That's my talk. With that, I'm very happy to take any questions. Thank you for inviting me and listening to me here.
John Fergala, NVIDIA again. So good talk. I'm just trying to understand the essence of TASI. So if I could summarize what I heard, Lano is looking at using open sourcing this tool to provide an instantiated environment to create file systems on demand, starting with Lustre and ZFS for testing purposes, but potentially using it as an environment for creating file systems on demand for your user base that you hope to be flexibly supporting other backends and other file systems. Did I summarize that correctly, or did I miss the essence of the TASI?
I would say the first half of what you said is the essence. Currently TASI is a tool for admins to sort of give them confidence before they spin something up in production that it works. We haven't yet considered whether it would make sense to, allow users to run whatever storage they want. But certainly the tool as it exists now could be used for that purpose as well.
I was actually interested in the AI mailing list bot, if you were going to unleash that on the actual list to answer questions, so I didn't have to do that.
No. So that is interesting. We started a work with Florida International University. Some of you may know Raju Rangaswamy. He's a professor at FIU. So he has a student that's actually working on, could you pipe these questions and get answers from the existing AI bots? And the answer is that we still need you, Andreas.
Let's thank John again.
Thanks, everybody.